When we're comparing two proportions, often we want to know not just are they equal to each other, but is one proportion larger than the other? This will give us a one-tail test, either a left tail or a right tail, depending on how the hypothesis is set up. So let's say a sample from one college has 2,051 Latinos out of 12,328 students. Another sample from a different college has 371 Latinos out of 2,441 students. We want to know, is the proportion of Latinos higher for the first college at the alpha equals 0.05 level? Or can we show that at the alpha equals 0.05 level? Starting to set this up with our 6-step process. First, we'll look at the hypotheses. The null hypothesis is that there's going to be no difference between them. That proportion of college 1 is equal to the proportion of college 2 that are of Latino origin. For the alternative hypothesis, we're trying to show that the proportion at college 1 is greater than the proportion at college 2. So that leads us to our picture then of what's going on. That we assume there's no difference between them, but because we're trying to show greater, that's going to stick us in the right tail. This is a right tail test. Now, what's interesting is I could have set this up, and the null hypothesis said the proportion of 2 is equal to the proportion of 1, in which case for the alternate, we'd be showing the proportion of college 2 is less than the proportion of college 1, and that would set up a left tail test. So you can actually switch up how the alternative and null are set up to give you the opposite tail. Just make sure once you commit to an order on your proportions, that is the order you stick with, because the one on the left is written down first. So college 1 would have 2,051 out of 12,328. And we subtract the second one, the one on the right, which is the college 2, the 371 out of 2,441. And when I do that, I get a proportion of 0.0144, which does in fact stick me in the right tail because it's bigger than our mean of 0. Then we go through all the calculations to find the test statistic. And you might remember that with the test statistic, it does take a few more steps to get the test statistics when we're working with two proportions. The first thing we need to know is the pooled proportion. And the pooled proportion, you remember, is all of the successes from groups 1 and 2 over all of the sample sizes from groups 1 and 2. So for us, group 1 had 2,051 Latinos, plus group 2 had 371 Latinos. Out of group 1 had 12,328 people. Group 2 had 2,441 people. And when I put that in my calculator, we get a pooled proportion of 0.1640. Knowing that pooled proportion allows us to calculate the standard error. Remember, the standard error formula is the square root of the pooled proportion times 1 minus the pooled proportion times 1 over the sample group 1 plus 1 over the sample group 2. So for us, that standard error then is going to equal the square root of the pooled proportion of 0.1640 times 1 minus 0.1640 times 1 over the first sample size, which is 12,328, plus 1 over the second sample size, which was 2,441. And when I put that in my calculator, we get 0.0082 for our standard error. Almost ready to calculate our test statistic. We still need to know the proportion of the first group as a decimal and the proportion of the second group. The first group had 2,151 Latinos out of 12,328 students. That's about 0.1664. The second group, the second college, had 371 Latinos out of 2,441. That's going to give us 0.1520. And so for our test statistic z, what we've been trying to find this whole time is the first proportion minus the second proportion divided by the standard error. Or in this case, the first proportion, 0.1664 minus 0.1520 divided by the standard error we just found of 0.0082. And when I plug that in my calculator, we get 1.75 for our test statistic. And once we know our test statistic, we're ready then to find the all-important p-value that will help us make our decision. Again, I notice on my picture, I'm in the right tail. If I go on Excel, Excel is going to give me the left tail. I don't want the left tail, so we're going to do 1 minus the norm.s.dist. That's going to give me the right tail that we do want with 1.75 comma true. And when I do that on Excel, it should give me 0.0398 for my p-value. And that p-value is going to help us then make our decision. We said alpha was 0.05. We said our p-value was 0.0398. This p-value is smaller than the alpha. It's gone beyond the reasonable doubt. Too little evidence in support of the null hypothesis. And so we can reject the null hypothesis because we have a small p-value. Which leaves us to our final interpretation. Again, the interpretation always focusing on the alternative hypothesis and whether or not we proved it. We did reject the null, so we did prove it. So we can say there is sufficient evidence at the alpha equals 0.05 level to conclude proportion 1 is greater than proportion 2, or in context, the proportion of Latinos at the first college is greater, matching the alternative hypothesis, greater than the second college.